This is Suman from the Dream Lab at the Indian Institute of Science, Bangalore. Our group works on distributed systems and applications. We present Ocularone, a drone-based assistive technology platform to help the visually impaired as part of the Kai late-breaking work. We explore a novel and socially beneficial application of drones where we plan to use drones as buddies to assist visually impaired people or VIPs. Existing means for the visually challenged to navigate include white canes and guide dogs. Recently, sensor-based walking assist, smart canes, and AI-powered backpacks analyze the surrounding environments using sensors and warn users. However, the VIP has to physically carry these wearables or devices, which can curtail their autonomy. Also, the field of view is limited by the orientation of the VIPs. We propose an approach that uses one or more buddy drones to autonomously shadow a VIP using DNN inferencing over video streams. The drones offer a flexible field of view that can reorient based on the position and direction of walk of the VIP. The VIPs themselves need to carry just an edge device like a smartphone or a compact edge accelerator. Ocularone is a platform for managing and coordinating a heterogeneous UAV fleet consisting of buddy drones, service drones, and mobile compute device. In our prototype, we have used Rise Tello as buddy drones and Jetson Nano as mobile compute device. We plan to use DJI Mavic Mini as service drones because of the available advanced sensors. We have explained the design goals of Ocularone. However, we pick and implement a few in this paper and leave the rest for future work. First is shadowing the VIP, wearing a hazard vest to identify them more easily. Left half presents the drone's view of the VIP and surroundings, while the right half is a third-person view of the drone autonomously following the VIP. This tracking is done fully using DNN models and a control loop algorithm to give feedback to the drone to change its speed, orientation, etc. The second goal is to plan the shortest path from start to destination. Once the VIP starts on an initial path, the drone shadows them. It helps them detect obstacles using computer vision algorithms. In case of a permanent road closure, it can help reroute using an alternate path to the destination. The drone can also provide situation awareness in case of a fall or an injury by informing their emergency contact. For example, in the video, the drone detects a fall. In the future, this buddy drone can even request a service drone carrying a first aid kit. We can also use vision-based algorithm for the VIP to interact with the drone and the platform using gestures. For example, in this video, Tello lands safely when the VIP stretches their arm out to 90 degrees. Lastly, we wish to scale our system to hundreds of VIPs in a city where drones are shared among users as part of a larger platform. It helps the system scale with fewer drones and reduces idle time, enhancing resilience and affordability. But we do recognize that drones are not a complete solution by themselves and have their limitation. Lightweight drones may fail in conditions like heavy rain, wind gusts, etc. These may also suffer from network variation. However, these can complement existing technologies to provide a better experience for the VIP. Thank you.